Good morning, good afternoon, everyone. Thank you for joining us here today on our webinar on RRFBs. We're going to be going through some presentation slides and flipping in and out of the webcam that you see here. On your screen, there's a little bar on the right of the webcam to increase or decrease the size of that. So feel free to adjust that. As we go through the presentation, we will be recording this. So a copy will be available and sent to you shortly after the presentation. So here today is, on your left is Paul Longley and James Wayner, Alicia Fells, and myself, Greg Miller with Carmanah. And we'll get going now. Questions, of course, you can post them by chat, or we can also take questions over the audio at the end of the presentation. So we're going to get started here right now, and certainly there's been a really solid attendance with this webinar. This is the second session we've done, and I think it's really indicative of the popularity of the RRFB device. This is a slide of that came out from Oregon State University, or Portland State, I should say, and just a combination of different studies and looking at the effectiveness of RRFBs. And I think it really does speak to why this device is so popular. It certainly is, the most effective crosswalk warning device there's been. It certainly does fill that gap between just the standard pavement markings and signs and going to a full pedestrian signal. And it's been, I think that's been a big reason for the popularity of the device. What we're going to be talking about today, looking at some of the key considerations for specifying a solar RRFB. We'll be looking at the energy balance, the concept of that, the importance of shading, and two important specification elements, the array to load ratio and autonomy. We'll then switch over and look at some installation applications, including some of the MUTCD requirements. And then lastly, we'll take a look at some of the warrants for the system and just some examples that our different agencies are using. But first off, why solar in the first place? RRFBs are a great application for a solar system, and largely because you have to have a unit on either side of the crosswalk, and so doing this with a power situation is typically pretty costly. Around 3/4 of all RRFB installations to date across the country are solar powered, and so that really does, I think, speak to some of the feasibility advantages, cost advantages going with solar, in the range of 1/5 to 1/10 of the cost when you look at all the considerations that you see here in terms of the power drop, the grid connections, and then the ongoing costs in terms of metering, etc. Time as well. Certainly a lot of time required to do underground checks with an easy powered application versus the solar system. So the key considerations and key concepts are really, we'll be looking at the energy in and the energy out and the balance between those two points. So starting in with energy in, the energy in is really a function of the solar installation available at the location. And we're fortunate that there's a very extensive database, NASA database available for that. So we can take a look at the solar data for the city, for the location that the installation is in, and that accounts for all the local conditions, cloud cover and fog, etc. Energy in is also a function of the system efficiencies, and that does vary considerably by manufacturer. And then lastly is shading, and shading is certainly is an important element in terms of the energy in. In fact, shading is the most overlooked consideration when what we see in specifications. This example here, we're facing south in this image here. This is roughly gets 50% of the available solar energy for this proposed location, where this crosswalk that you see here. So that would take the solar data from NASA and chop it in half, basically, based on the shading of the local situation. And what would happen here is this building to the left would provide shading during a late morning time period. Then there'd be full exposure in the middle of the day because this is facing south. And then later in the afternoon, the buildings on the west here would provide more shading. So this is a really important element that needs to be considered. This graph here shows the effects of shading. And this example here is based on Seattle, Washington. Seattle is generally the worst case solar in the U.S. and most of the Canadian market as well, on the west coast, where we're located here, is the most challenging. What we're seeing here is the effect of a number of activations on the left-hand side, and how the shade derating affects the system in this location. And this is based on 320-second cycles. This is actually based on 400 cycles without shading, and then down you can see if the shading is 50%, like in that example previously, we're down to 100 or so activations. And what that means is that the system can support 120-second cycles, 20-second activations per day, year-round, that location. So obviously there's lots of crosswalks out there where that's going to be plenty of capacity, but there's other crosswalks where you're actually going to need more than that. Our approach has been here to develop two systems. So we have two different models, a larger model, the SC315, that does have a greater capacity. And in this example, you can see the capacity it has. Even with a 50% shade derating, the system still is capable of over 600 activations per day, year-round, in that location. So to summarize, energy in is a combination of the solar panel power, the power coming from the panel, the number of sun hours, which is from the location, dependent on the location, the charge efficiencies of the system, and then, of course, that shade derating factor. Switching now to energy out. Energy out is a function of the following: the number of actuations at the location and the flash duration, as we just saw in the previous slides. It's also a function of the efficiency of the optical system, and that includes the LEDs, the LED driver, the actual optics with the system, the efficiency of the energy management system, the controller, and that's inclusive of all the elements that need to run the system. And then, of course, the push button as well. Some of the push button applications require a voice message, and that option does take considerably more power, and there's some different settings that need to be considered within that as well. So there's a number of things to sort of factor in when looking at the energy out. There are many variables. This slide here, this is a snapshot of our energy balance worksheet, just to show you an example of all the different variables that actually get factored into the system. But essentially what we're looking at is the energy out is a combination of the standby power, the power that the system consumes continuously when it's off. And that a big factor of that might be shading, or it might be the wireless technology. Wireless is a factor there. So it's the standby power plus the power required when the system is actually flashing, and that, of course, is multiplied by the number of actuations, or the time that the system is going to be operating in. So this brings us to a very important concept and also specification, and it's called the array to load ratio. And it's simply a ratio of the energy in divided by the energy out. This ratio should be at least 1.2 to 1. And This is really important for two reasons. And the first is that it provides a significant buffer to account for estimations and variability in the solar energy, the system usage. And second, a rate of load ratio of at least 1.2 to 1 enables the battery life to be able to be maximized. And we'll take a look at that a bit more in a minute here. This is a comparison of some rate of load ratios in different examples of different products that are out there. And one of the things that you can see here is that it does vary considerably. And second, that you'll note that the solar panel size for each of these examples is also listed. And the solar panel size isn't the whole picture in what calculates the rate of load ratio. And that kind of leads to, we see this spec, this type of specification quite frequently, where this says the solar panel shall provide 55 watts of peak total output. This is really only half the equation. And as you just saw there, the rate of load ratio is what really should be specified. So the rate to load ratio does have a direct impact on, essentially, on the battery life. What we're looking at here is the daily depth of discharge of the battery. On the left is the number of cycles. There's one cycle per day in terms of the charging and discharge cycle of the RRFB. And then on the right is the depth of discharge. So for a system that has a small rate of load ratio, the batteries are going to be discharged more aggressively, which translates into a direct reduction in terms of the number of cycles that the battery is capable of supporting. When we can keep the depth of discharge at 10% or less, you can see that the number of cycles increases dramatically. And this is a really key point in terms of looking at specifying the system to ensure that the system is going to have battery lifespans that will go designed for 5 years and plus. A lot of the applications that we see in practice, we've got products in the field that are getting close to 10 years in the field with the original batteries, and that's indicative of what you can see here. And it gets to the point where the batteries are actually at the shelf life of their rated usage. The second important specification to consider is autonomy. Autonomy is defined as simply the number of days the system can operate without being charged. It is calculated as the battery capacity divided by the energy out per day. There is, going back to that solar database from NASA, this database does provide a recommended autonomy value for each location. And so our guidance, and certainly industry practice in the solar industry, is to make sure that the autonomy meets or exceeds that recommended value for the location. We take a look at the different autonomy values for different RRFBs that are in the marketplace. You'll again see that there is a great amount of variability. You'll also note here that battery size alone does not determine the autonomy. In this example here, there's an RRFB with a 35 amp hour battery, the black line, and then the Carmanah SC315 also with a 35 amp hour battery. You can see the autonomy varies considerably because of the differences in the energy out between those two models. You'll also see that the Carmanah R920 model with a small 14 amp hour battery capacity has a greater autonomy than systems that have larger battery sizes. And this is because the amount of energy to run does vary considerably. This example here just shows the difference in energy required to operate per day, and it can be up to 5 times the amount of energy depending on the model that you're looking at. The energy consumption is composed of a number of different variables, including the charging efficiency of the system, the radio, the wireless. Because an RFB, when you push the button, there needs to be a wireless signal that goes out across the street. So both sides, or all lights actually in the crosswalk will flash as soon as the button is actuated. The devices need to be listening all the time, and because of that, the wireless can take a considerable amount of energy. The Carmanah system, we have spent a lot of time developing the radio technology to be extremely energy efficient, so you can see the differences here. And then lastly, looking at the lamp or LED losses, including the driver, and then just the optical efficiency of the system. So what's wrong with this specification? There's actually a couple of things here. The spec reads, the battery shall be rated at 40 amp hours minimum. The battery shall be solar charged with the capacity up to 30 days autonomy, et cetera, et cetera. The first thing wrong with this specification is that it's calling out just the battery size, and battery size alone, as you just saw, is not an accurate way of, or effective way of specifying the system. The second component wrong with this specification is that the autonomy is specified without any usage data behind it. And if you don't have any usage data, it's actually a meaningless specification. So, and the third element that's wrong with this specification is that 30 days autonomy is actually completely excessive. When we look at the NASA recommended autonomy values, it ranges by location, but it's often between 5 to 10 days. So we don't see locations requiring 30 days autonomy. So to summarize, in terms of developing a performance-based specification, we need to look at the number of actuations that the system needs to be able to support for that location. The array-to-load ratio needs to be specified, and that needs to be specified and recommended to be at least 1.2 to 1. And it also needs to consider the shade derating for the location. The required autonomy for that location also needs to be specified. And one thing I should point out here is that this information should be readily available from from the manufacturer, and certainly we spent a lot of time developing the tools, and we have the ability to provide an energy balance worksheet, for example, to provide this information to you to make it actually fairly straightforward to specify properly the product. This performance-based specification is how you're going to ensure a reliable system, year-round operation of the RFB. And it's also going to ensure that the system's sustainable, meaning that it's going to have year after year operation, and like I said earlier, a 5-year design life for operating on those batteries, subject to the actual location and how it's being utilized. So we're going to switch gears here and look at applications, and briefly take a look at some of the functional considerations before we dive into the actual applications for the product. So again, I'm switching on the webcam, and you can see the web. You can adjust the size of your webcam based on what you see here. But there's 3 functional considerations to look at with the product. One is the pull type. And that's one of the really, I think, exciting things about the technology and how it's developed, is that the system now is designed to be small enough here that it can mount on standard signposts, 2-inch round or square signposts. The system itself has all the control electronics and batteries all mounted inside what we call the solar engine here, so that it doesn't require a separate cabinet. This is the R920 model. So that's, I think, a big element in terms of considering a functional consideration for specifying the product. The second thing is how to configure the system. And we have spent a lot of time with this product developing the configuration to be as straightforward as possible. There's an onboard user interface that I'm sure you can't see in the screen here, but you can go through and basically select the different menu items that are listed here on the inside of the solar panel and adjust things such as the flash duration with the product. And other things in terms of configuration for the wireless, and in this product we've designed it so that there really isn't any configuration required for the wireless. As soon as the batteries are connected, the product communicates to the other RRFBs in the system. And the last consideration to look at is the light bar, the functionality of the light bar. We've designed the light bar with a two-piece construction that allows the light bar to actually rotate in the field and then be secured in place based on aligning us to the oncoming vehicle lane. So three elements there in terms of considerations for how the product functions. So now moving to applications, and to start with, we'll go through some of the key elements, requirements from the MUTCD. This is a combination of what came out first in the interim approval in 2008, as well as some of the interpretation letters that have been out since then. And these are really important. I mean, the overall concept here is that RRFBs have been proven to be extremely effective for uncontrolled marked crosswalks. And Federal Highway's position is we want to keep it contained just for that application. So there's certainly a lot of interest for using it on a timer, for example, at a school zone situation, or on a warning sign, these types of things. None of those things are allowed. This system is only for uncontrolled marked crosswalks. The devices have to be mounted on the crosswalk signs that you see in this picture here. The system has to be pedestrian actuated, otherwise the units shall remain off. Again, so if you see a specification come through that calls for the system running for up to 60 minutes or running on some sort of calendar, that's not allowed, strictly not allowed with the RRFB. Number 3, it must turn on instantaneously and simultaneously. So as soon as that push button is actuated, both sides of the street need to come on immediately and flash. We've noted some other manufacturers have a slight delay with the system once the push button is actuated. We specify that the responsiveness of the system in our specifications. It's an important thing. It is a warning device. In our opinion, as soon as that button's pushed, these lights need to turn on. And also, sorry, they also need to flash in a coordinated flash pattern and turn off simultaneously, and that's achieved here with the wireless system. Number 4, the flash period shall be initiated for each pedestrian actuation without any delays. And what this means is that if there is multiple people using the crosswalk, and say it's someone's come in, pushed the button, and they're halfway through, 10 seconds into a 20-second cycle, and someone else comes into the crosswalk and pushes the button, the system should go for another 20 seconds from that second button push. That's a requirement from Federal Highways. It was clarified. And again, because it's a warning device, there is no feature or provision to have any sort of delays that you might have with a pedestrian signal type application. Again, the units must be mounted at the crosswalk on the W11-2 or the school signs, in between the sign and the down arrow sign that you see in the picture here. They have to be on the left-hand side and right-hand side for each approach to the crosswalk. So in a two-way roadway, you need to have this light bar as back-to-back, essentially. On a one-way roadway, there can be just single-sided. They can be overhead or in advance. The advanced units are in addition to the side-mounted units. The overhead units can replace the side-mounted units, although it's recommended that the side-mount units be used as well, and we'll show an example of that here in just a minute. And also, the system must not dim during the daytime. So this is a interpretation that came out. The RRFBs, the intensity of the light This is important to know the difference here. The intensity can adjust during the daytime so long as it remains above the minimum required by the specifications. And that's the SAE J595 Class 1 spec. So, but the system can adjust the output as long as it's above that spec. And we, in our system, the Carmanah system, we do have that ambient auto adjust feature, which can be disabled, but we recommend using it. The system can it can be many times brighter than the specification, and it will run many times brighter during full daylight compared to cloudy conditions. And this is adjusted based on a photocell, and its response to the reality is that in a cloudy conditions, the human eye will see this light source to be much, much brighter than you do in a full daylight conditions. And so the technology is there to respond to that. So looking at the actual configurations, this is the most typical configuration where you have units on either side. And again, on each approach to the crosswalk, the driver must see the light bars on the left-hand and right-hand side, like you see here. Again, the advanced units can be used, and usually instead of the down arrow sign, they're replaced with the ahead sign. These cannot replace the units at the crosswalk, but they can be mounted in addition. The solar and wireless features of the RFB really lends itself well to utilizing these ahead units. So anytime there's a horizontal or vertical curve, that provides, or other issues for sightline problems, the ahead is a good option to improve the visibility of the system. And again, one-way systems, you can just have single light bars mounted on the pole. If there's a median, it is recommended to mount that unit that the driver sees on the left-hand side on the median, and it's a great application for the RFB, putting that light source right in the direct field of view of the driver. This is an example of one, and in this example, it's done actually a little bit differently, where there is three systems visible on each approach. So each pole has back-to-back light bars on it, and I personally think this is a great application for it. Just has added visibility on that far left unit. In this situation, it works really well. You'll also see here in this example the stop ahead, the stop bar that's mounted in advance of the crosswalk with the appropriate signage. The median can also be mounted the median units can be mounted on two separate poles instead of a single pole. And this all just depends on the width of the median and the actual road configuration. For example, here the median would be too wide to ideally put one pole in that location. So this is where two poles can be used. Parallel crosswalks. This is a good application for the RFB, and I think particularly when we look at greenways, where you have a lot of bicycle traffic, you want to eliminate the need to cross over to one crosswalk. So parallel crosswalks are used. And then on this approach, on this example, the RFBs are visible on the median and on the far right-hand side to each approach that you can see as the yellow. And the push buttons are actually mounted on in all four corners. This is an example here where there's a range of things that you can do in terms of the actual configuration. For example, depending on the feasibility of trenching the light bar and push button wiring, you can have the solar engine mounted on the, for example, on the top right and bottom left corners, and have the wiring for the median mounted light bars run through, run from the side, eliminating the need to have a controller or solar engine mounted on the median. That's just one example. There's all sorts of different ways of doing these types of arrangements, and we certainly encourage, if there is a specification or application that you're looking at, we'd be happy to review that and recommend some different options in terms of how the product can be laid out. This is another example of parallel crosswalks, and this setup, the agency actually had just the back-to-back RRFBs in the top right, bottom left. The other two corners of the intersection are just push buttons. So that's a different way of doing it. Again, depending on the distance between these two crosswalks. The other option is to have single-sided or double-sided RRFBs on all four corners. So there is a range to do things, range here, and all different applications fall within the guidelines of MUTCD. So it really just becomes engineering preference. And then now looking at overhead. So overhead applications, two-way roadway. Again, the requirement is to have overhead units, and the recommendation is to also put side-mounted units as well. In this example here, how it's configured, the solar engine is side-of-pole mounted, powering both the side unit and the overhead unit, and then the wireless communicates to the overhead units on the other side of the roadway and the advanced units. So a range of different applications available there. And here you can see a combination of a median-mounted unit as well as the overhead-mounted units. Roundabouts are a popular application for RRFBs as well, and these are essentially a series of one-way crosswalks. One of the things that's important here is that you can have different channels set up so that one crosswalk won't inadvertently actuate the other crosswalks. So you can have channels set up, and it's again using the user onboard user interface, which is fairly straightforward, very straightforward to configure. You can adjust that channel as needed. Sometimes, like in this example here, the major legs of the roundabout will have the RRFBs mounted on them. Again, you see the RRFB on the right-hand side and on the median for the entrance into the roundabout, and then again on the median and on the right-hand side for the exit of the roundabout on the through legs. And on the minor legs, actually, there's no, it's just pavement signs, or signs and pavement markings. Looking at a couple of different warrant examples. This is from the City of Boulder, and it's a fairly conservative warrant, I would say, and there's a lot of agencies that are now using the RRFB in applications sort of beyond what you see here. But what we're looking at, the factors to consider are the pedestrian volume on the left and vehicle volume per hour on the bottom, and the different bars here are the crosswalk widths. And so when it gets to be above a certain threshold, RRFBs are no longer recommended. And but there's a fairly large area here where you can, of course, consider using RRFBs or looking at the hawk or pedestrian signal as another option as it kind of moves along this chart. This chart is for 35 miles an hour or less, and then you can see the lines, everything kind of shifts to the left here when speeds become greater than 35 miles an hour. Just one example of of an agency that has spent quite a bit of time with this device and developing their warrant system for it. Another example is some research that has come out of Oregon DOT, and this is a decision matrix which we're finding a lot of agencies are referencing this as a guideline or a starting point anyhow in terms of how they're determine where RRFBs fit. Looking at the different variables, I'll just blow it up here for a minute. Speed limit, 40 miles an hour or greater. If it's greater than 40, it goes straight to a pedestrian hybrid beacon. Whether there's a median present. If there's a median present, then it will change the decision matrix here. Whether there's visibility issues, whether there's more than 3 lanes of traffic, and whether it's high volume, and that's defined elsewhere in the document. And then lastly, whether it's located in a high-risk environment, such as near a transit stop, or whether there's a lot of visual clutter around schools or senior centers, shopping centers, etc. And then based on that, the suggested treatments on the bottom here. The purple pedestrian hybrid beacon, the light blue is RRFBs without a median, and then the black is RRFBs with a median, and then the red is simply just your standard crosswalk. So lots of different resources that are out there, depending on the different scenarios. And I think we are seeing that the RRFB is growing in terms of the number of applications it's used for. And certainly the research that was done in 2010 by Federal Highways, a lot of that came back. A lot of the installations were on 4-lane roadways with vehicle volumes in excess of 10,000 vehicles a day. And those examples, there's a really positive yielding performance even in those types of scenarios, with or without a median. And certainly, a lot of this initial research didn't have the overhead mount as well, so that adds another option for it. So we covered quite a few different concepts in terms of the rate-of-load ratio, autonomy, and some of it may come across as sounding a little bit daunting, and it really doesn't need to be. And that's because partially there is some really sophisticated tools that are now available, and also because all that we need to do to be able to assist in specifying the right system and ensuring that the system is going to be reliable is the location and the actual usage. And by location is basically the intersection. And from there we can take a look at the shade derating. So we have a capacity calculator. This is an online tool that is available for anyone to log in and use. And from here you can punch in the location, and it will provide you with a snapshot in terms of the number of actuations that the system is capable of. You can see the two different models here based on this location. The key element here is the shade derating, and those variables, again, we recommend contacting us. We can take a look using a Google Street View and very quickly provide an input in terms of what the shade derating might be for that location. And from there we can provide, basically build a very reliable specification. So with that, we're going to open the floor to questions here. Turn on the video cam. Again, if you wanted to move the video cam around, there's a bar on the side of it. You're welcome to do that. We'll be taking questions online, and as well as if you wanted to voice any questions, you need to raise your hand. And do you want to explain, Lisa, where we do that?
On your sidebar where there is all the options to view, there's an orange arrow. There should be a button on your screen that has a hand. If you want to ask your question vocally, you can press that button and we'll take them in the order that they come by turning off your mute. Or you can type in your question over chat and we'll answer back vocally. There are a few here, Greg, if you wanted to.
Okay.
Let you.
Okay, for the first question that we have is for square signpost mounting. Have the units been tested to the match requirements, such as the post get hits and breaks away and the units stay attached to the post? That's a good question. We actually had AASHTO, NCRHP 362, is that right? Crash testing done a while back on our 24-hour flasher, which is essentially the same size system as the R920 here. And we do have that crash information available. And essentially, it's actually a really good design, having the solar system such that the mass is A, small, and B, mounted at the top of the pole, so that the pivot moment is at the top of the pole during crash. Feel free to contact us. We can provide you with the NCRHP information on that. The second question here is what percentage of RFB systems are solar in Western Washington, of Carmanah RFB systems? That's a great question. In Western Washington, I would say at least 80% of them are solar powered. You know, despite the Northwest being really challenging with solar, whereas with a 315, the SC315 model in particular, the system can handle even situations where there's a fairly high amount of shade. It's those extreme situations where it's a combination of shade as well as high usage that it might get to the threshold where we'll look at it and say, actually, an AC-powered system is what is going to be the best for that location. But overall, I'd say over 80% of them are solar in Western Washington. My next question, what is a reasonable spec for autonomy based on the state of Kansas? Do you want to?
Yeah, I had a quick look at that, Greg. It looks like about 8 or 9 days from what I'm seeing from the NASA. If I've got my location correct, that's for Wichita.
For Wichita, okay. Yeah, so just as an example there. So it is city specific, but like we say, I mean, is it fair to say it generally doesn't exceed 10 days, you know, based on?
Not from what I've seen, not from my experience in North America.
Yeah. Okay, some good questions there. Next question, do RFBs satisfy the MUTCD and PROAG requirements for multi-lane roundabouts? That is a great question. And I believe that there is some direction to look at requiring the use of RFBs at multi-lane roundabouts. I'm not clear on whether that has been determined or not. I know that there is some research ongoing with that. PROAG does have some considerations for the use of the voice message push button with the device. That is an option that we have available. As I mentioned earlier, it is an option with the SC315 product only, and not the R920. My understanding is that the requirements for the RFB regarding the use of that for PROAG is still up in the air. So if anyone has more information on that, I'd be happy to great if you can share that. That's what we know on that one.
We have a question over the phone.
Okay.
Make sure it works.
Sure, we've got a question. You want to ask that question? Is there a question by audio from Joe?
It looks like he's also typed it in, so we can hear.
Okay, sounds like we'll just respond to that by reading your question here, because there's quite a bit of feedback. Does Carmanah offer maintenance contracts? We do, or warranty. We do provide a standard 3-year prorated warranty on the product. We don't get involved in maintenance contracts, though. We do have a network of authorized distributors, and in turn, our distributors have very strong connections with contracting companies, and many of which do have those sort of maintenance contracts. So if that is something that you're interested in, we can sort of connect you with the appropriate distributor, and who will in turn provide a contractor that can do that. Next question, we are planning to install dual-sided RFBs at parallel crosswalks on a 4-lane roadway with a median. So there are 6 installation locations, all 4 corners plus the median. What would you recommend this setup? Let's take a scroll back to that median example. Bear with me for a second. So this is, I think this is what we're talking about here, and the difference being that the top right and the bottom left units would have an RFB on it as well. And you know, my experience just with seeing how some of these have been configured with that 3-unit system If the median is such that that far left unit is visible, by all means, I think it just provides really good visibility, particularly in high traffic volumes, being able to see the unit on the far side of it. It is, I would suggest that is a good application for it. One of the other considerations is, when you push the button on one crosswalk, should both crosswalks flash or not? And there really isn't any recommendations on that, so it does fall onto engineering judgment. The good news is the systems can be configured in the field, can be adjusted in the field to either have only one crosswalk come on or have actually both crosswalks come on. And whether to do that or not, I think really just depends on the actual intersection, the distance between the two crosswalks. And again, what's nice about it is that you could set it up to have them all flash, and then if it looks like it's becoming a distraction or it's excessive, for example, then they can be configured differently. So I hope that answers that question there. It's a good question. This one here. Okay, so 20-second activations were listed for the 920 product. How much does efficiency decrease when the activation increases to, say, 40 to 50 seconds? So that's the first part of the question. So it's a good question. I encourage you to take a look at our capacity calculator, where you can go and adjust. You can actually adjust those settings, and you can see. But it does certainly impact. You can see the drop-down menu here is defaulted for 20, but you can adjust that. It does change that significantly. So it's important to specify that for sure. And also, what are the rated battery and solar panel life for the product? The battery life is dependent on the ambient temperature of the location, and it really is dependent on how significantly the product is used. The design life for our design goal with the product is 5 years. The system does have a 3-year prorated warranty with the battery. And the solar panel itself, solar panels are, is it 20 or 25 years?
Oh, it's a minimum of 20, typically 25.
Yeah. So solar panels are certainly designed for that long lifespan. Another question we often get is in terms of the LED life. And the LEDs, in a situation like a LED street light where the LEDs are being driven very hard, it's certainly an important consideration. In this example, in this application, we drive the LEDs with very low drive currents to maximize the efficiency for the solar, and that combined with the fact that the system stays off for the vast majority of its lifespan means that those LEDs are going to last for a very, very long time. Sorry, next question. How often do the solar panels need to be cleaned or maintained? Would bird droppings or dust affect system efficiency significantly? Good question. It can. Do you guys want to speak to that in terms of how significant we've seen degradation on?
For the actual bird nest, typically there's a bird's turn that can be installed on the edge of it if that's an issue with it. But as far as general dust and accumulation of debris, that doesn't really tend to be an issue. Usually rain will wash it away, and also the steep inclination of the panel allows most of that to be cleared off. So in our experience, it's not really a concern. If it is of an interest as far as performing a solar simulation, we can always apply a small degradation factor for that, anywhere from 2 to 4%, if you really wanted to approach this with a very conservative simulation, and we could then produce the results based on that.
Going to the next question here. The presentation slides will be available. Yeah, so that question's asked before. Yeah, we'll be making those shortly. An email will be sent out shortly after this with a link to that. Do you use the standard MUTCD pedestrian walk speed for the duration of the flash? If not, what do you use? Great question. It really is. It can be specified, or it can be adjusted. The system defaults to 20 seconds. It can be adjusted from 10 to 60 seconds with 1 second increments. It is, I would say that I think it's 3.5 feet per second, plus an initiation time of, I think, somewhere between 5 to 7 seconds. That seems to be sort of general practice, which is, I think, the same as the pedestrian walk speeds. Oh, okay. Yeah, actually, it just has some input here. Thanks, Paul. You can speak to that. So it's been changed to 4 feet per second from 3.5 per second. That's a newer specification. Again, I think it is judgment depending on the user types as well. Are these units compatible as replacements with the older spot device units? Will they talk to each other? Good question. The Spot Devices is a company we acquired some of the assets of that product, of that company from last year. The short answer is no. It's very different wireless technology with our product, and one of the big reasons that we're able to get the efficiencies out of this product is with the wireless technology. But as a result, there is no compatibility with those older Spot Devices products, unfortunately. Do you know if there is solar with any AC backup options? No, we haven't seen that officially. We haven't seen that sort of configuration. And often, you know, if you're going to run power to the unit, then the solar itself really does become redundant. You know, what I think is important with, and I hope we sort of demonstrated here, is that with the right consideration of the application, solar system can be extremely reliable. The SC315 model that you see there in all but very extreme applications has all sorts of capacity, and in many applications has far more capacity than what's required for the situation. So we really can provide a very high level of reliability for the system, making AC really not required. And then, like I say, in those extreme situations when it is required, it really doesn't make sense to combine solar with AC. Next question. In downtown Seattle, is there too much shade from tall buildings, or does solar still largely work? Do you guys want to speak to that in terms of shading? Yeah.
We have seen situations where there's a lot of tall buildings present, and really the best way to answer that is to look at an individual or specific location. I don't think there's generally a good answer there, honestly. It's much different in rural locations, obviously. So, you know, I've been to Seattle. I know what it's like in the winter. I really need to see the location to give you a good answer on that, honestly.
Yeah. And we certainly, I mean, it's very easy for us to go and jump on Google Street View. Again, all we need is the intersection, and we can look around and provide that feedback and that input for you. Next question: are the controller components able to be shipped and configured such that we can install in our own signal cabinets with communications, etc.? No. Quite clearly, our products are highly productized, meaning they're all designed to be built and come as productized units. So we don't have the ability to put out different components, etc. What you will find with our products is that they are designed to be very easy for installation. So it comes out from the factory all pre-wired. And really, so that high-level productization is really has been our design objectives, and because of that, you know, we really don't have the ability to provide different components and provide the system at a component level. There's other things that would add to the complexity of that, such as the light sensor, which, by the way, the R920 is mounted up at the top of the unit along with the antenna. these types of things that we found it's best to have those built in the factory rather than having that to being done in the field. Last number of questions here. Do the RFBs work with in-pavement flashers? No, the RRFBs are different products from the in-roadway systems. We have seen, I think, some examples where agencies will use an output from an in-roadway system that can trigger the RFBs if that output is basically the same as a push button. We have seen that from time to time, but overwhelmingly what we're finding is that the RFB is being used to replace the in-roadway warning lights. The research is very compelling that shows that RFB is more effective than the in-roadway warning lights, and in addition, the RFB is provides far lower maintenance and installation costs. So a lot of those in-roadway lights are being replaced with RFBs completely. Yeah, we have time for just a few more questions here. We'll just go through them quickly, and then any questions that we don't get to here over the phone, we'd be happy. We will be responding to by email. Where we had, does the Carmanah meet the SAE J595 requirements for not falling below the minimum level of intensity during daytime dimming? Yes, good question, and sort of alluded to that earlier. The system during our ambient auto adjust feature, even at the lowest setting, the system still runs above that nighttime intensity. And in fact, even our nighttime intensity still runs above the minimum requirements for J595 Class 1. So that's a very good question. It's important. And I know there's been some confusion in the industry, people talking about how that light adjustment is considered dimming. So just to be clear, it's only dimming if it goes below the specification. And like I say, our product always stays above the minimum required intensity. The question here, what circumstances should trigger use of overhead flashers? It's a great question, and I think the overhead does present considerably more cost for the system. I would say a situation where a median is not possible, where things like curb extensions aren't possible to bring the light bars into close view, or a situation where there might be vertical curve or other sightline issues that make the post-mounted units sort of be obstructed in terms of visibility. That's when you consider the overhead mounted situation. And otherwise, I think the vast majority of RFBs that have been installed have been post-mounted, and I think the results speak for themselves. Okay, final question here. Let's see here. Is there a concern about mixing RFBs in neighborhoods that already have in-pavement lighted crosswalks in terms of driver expectations? That's a really good question, and I don't think so. I mean, judging by the number of agencies that we've spoken to that have had the RFB as the first installation, the driver expectations have been, everyone seems to be very impressed with the expectations that the system comes up with. Yellow flashing lights at the crosswalk, I think the driver can connect that with other warning devices, including in-roadway systems that they may have seen in the past. And I think, honestly, a lot of the in-roadway systems that are deployed right now, the visibility of them is, because of the age and wear of those systems, are often, from what I've experienced, really, really dim. So I think the RFB would provide a much superior reaction from drivers. And I don't think that there would be any confusion based on the fact that new installations in locations where there might not be RFBs anywhere in the vicinity, those have been received very positively. Okay, we're going to wrap it up. I know there's a few questions here that we didn't get to. Great participation. Thank you, everyone, for your time. And again, do not hesitate to contact us with your application. We're happy to review it and provide recommendations. We can provide written specifications as well. And like I say, the recording will be available on this webinar, and we will answer the remaining questions here by email. Okay, we're going to sign off. Thank you very much, everyone, again, for your time.